sticking with offshore, there's a new venture from Myersk to, oh wait, Rosemary. Yeah, I knew it. Jump in there. Maersk.
You did that on purpose.
No,
You did that on purpose.
Maersk.
Yeah, that's
All
better.
right, there we go. You're welcome, listeners. You're welcome. Welcome to Rosemary's Grammar Hour. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the Uptime Podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the Uptime Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's episode, a lot of topics. We're going to talk about satellite outages, downing some wind turbines. We'll talk about offshore wind turbines potentially messing with ships' radar. Lots of other battery issues, battery technology offshore. We'll talk about some policies over in Europe, their supply chain woes, layoffs with Nordex, Siemens Gamesa, and others. And lastly, this will be Rosemary's big time to shine, some two-bladed floating wind turbines that are supposedly going to be deployed by 2024. So before we get going, be sure to subscribe. You'll find in the show notes below Rosemary's YouTube channel, where she continues to churn out great new renewable energy content, and Uptime Tech News, our weekly newsletter, keeping you up to date with the new podcasts, videos, news from around the web, and more. So let's get right to it. So first on the docket today, there was a satellite outage, which is actually coincided, but they're not sure if it's related to the war in Ukraine between Ukraine and Russia. But 5,800 of Enercon's turbines have been disrupted. There's some of the remote operations they're monitoring from satellite connections. Alan, what's your take on the situation? I mean, this is the first we've really heard of this since we've been doing this show. But obviously, as things get more and more interconnected with the web and all these remote monitoring, we're probably going to see more of this.
Yeah, we are. And a lot of internet runs through Ukraine. Like a lot of software development happens in the Ukraine, and it's not surprising that the remote operations happen through Ukraine. That would seem kind of obvious because so much does run through the Ukraine. The funny thing was Enercon was discussing this as responsible operators have a backup system. So that left everybody else as being unresponsible operators, which doesn't make a lot of sense to me. So what are you going to do, right? What are you going to do? You got to prepare for every conflict around the world to make sure your turbines are connected to the internet. That seems like crazy talk, right? But maybe you do. Maybe every turbine needs to have a cell phone connection. Maybe every turbine's got to have a satellite, Elon Musk, SpaceX Starlink system connected to it, because that's what it's starting to feel like, because we're all interconnected. And when we have war in one place, it seems to affect everybody around the world. And Rosemary, do you guys see any disconnects in Australia from the Ukraine war situation?
Well, my internet has been really shockingly bad over the last few days, but I'm attributing that to a combination of Australia never having taken broadband infrastructure seriously for some reason, and secondly because we've just got the most ridiculous amounts of water and flooding and rain storms. So I'm assuming that it's that. We are geographically pretty far away from Ukraine, so I'm not immediately rushing to attribute it to that.
Well, Rosemary, we've talked about engineering things to be as bulletproof as possible where they're financially feasible. So, would you think that having backups for your backups, and like Alan said, maybe you have a secondary internet source ready to go, do you feel like that would make financial sense for some of these companies as they become increasingly remote and increasingly monitored through the web and other means?
Yeah, I'm really surprised. I don't think this is necessarily a financial balance to make. I'm surprised it's not regulated, that they have to be able to continue to operate even in a satellite outage. I'm surprised that they can't. Obviously, distributed energy through a lot of wind turbines, a lot of solar panels, it's harder to disrupt that than it is to just bomb a large coal or nuclear power plant. But I'm sure that those really big centralized power plants have backups in place so that if they lose their internet connection, they can continue to provide power. And I obviously don't know enough about the details of this story, but it's nearly unbelievable to me that it's possible to have a wind turbine that needs a satellite connection to work. I'm surprised, and I think that definitely that they should have those at least a couple of layers of redundancy in place.
Well, it seems like the way cars are. I used to work on cars when I was in high school. My brother and I each had our own old, like he had an old Mustang, I had an old Ford Bronco. And then when you work on these cars that are almost entirely mechanical, you start to wonder like what actually has been improved by the incredible amount of electronics added to modern cars. Like, yeah, they're definitely more fuel efficient. There's a lot of benefits, but ultimately, like you can't even work on your own car anymore. Like, and so this seems like it's sort of mirroring that same thing. Like ultimately a wind turbine is a mechanical device. You wonder at what point you're like, man, this trade-off, these things are just too complicated and require too much complexity to fix or to maintain, or too many things can go wrong. I don't know if that's where this is going, but I think you're right that redundancy needs to be pretty significant and simple. So moving on, Alan, this I'm going to throw to you first. There's some reports that offshore wind turbines might interfere with ships' radar signals. So obviously, on our other podcast, Struck, we've talked at length about how 5G and that rollout has been, difficult around the world because they've been worried that 5G would mess with the radar systems of aircraft. Obviously, it's a huge concern because we don't want a single plane to go down with passengers in it. Obviously in the sea, the stakes are lower, but do you see this being an issue? I mean, they obviously do so much in aerospace. Wouldn't they have maybe sort of knocked some of these kinks out where it would maybe trickle down to the shipping industry?
It's going to affect radar systems. You got these big, massive 1,000-foot objects in the water. Absolutely, it's going to affect radar systems in ships. The question is, does it matter? And were you planning on weaving between these wind turbines for some reason where you need to navigate between them? Hopefully not, right? But yeah, it will interfere with radar systems. And there's been a lot of talk in the last couple of years, kind of pre-COVID, about putting coatings on the turbines so that the radars don't bounce back and it causes less interference. Yeah, sure. But I have seen nobody implement it. So even though it's a discussion point all the time, no one's implemented it. And on the FAA side, on the airplane side, we have wind turbine farms everywhere in America, around airports or at least close enough where it matters. And the radar systems do have trouble there, but they've used, of all things, software to eliminate those problems. So those wind turbines aren't moving around. They're fixed objects. You know where they're at. So they use software to sort of eliminate the backscatter from the wind turbines. That's the easiest solution, but in the case of ships, are you going to upload new software to every ship around the world so the radar system works? Probably, yeah. Rosemary, there's really no other solution, is there, besides new software, a new subscription service update, something?
It's funny. Actually, my mum she's a writer. She writes about engineering and wartime things. And her current book, she's researching radar a lot and some, things to do with astronomy as well. And so I was reading an early draft of the book that goes through the early history of the development of radar. And I mean, there was problem after problem after problem. It's like really simple in theory to, bounce waves off surfaces and then read it back. But the early history of radar is all about this thing messes up the signal on this weather conditions and, whatever. Time after time, they had to, get smarter with their radar. And I mean, it's already incredibly smart. And I just feel like this will be one extra thing that they have to add. I'll be pretty surprised if, the radar people can't find a workaround for the wind turbine issue. What's the implication that instead of solving a problem with radar, we just stop offshore wind, even though the whole rest of the world is managing to cope with ships and offshore wind farms, but the US can't. I mean, it seems it seems highly unlikely to me.
Easy. Go USA.
I'm saying I have full confidence in your people to solve this problem without having to pull out the whole of the US's offshore wind farms.
I don't know.
That's crazy.
There's some radar salesperson thinking, man, I can buy a new boat because I got to sell thousands of these new updated radars. There's someone thinking that. I guarantee you there is. And they're probably right, because they're probably going to have to sell a bunch of new radar systems. And okay, that's cool. But yeah, it's just the world changes so fast. You can't expect to use any piece of hardware more than 5 years without having some sort of update. So,
Yeah, I bet it'll be an update. Exactly. I don't think people are going to be buying new ships and new radar
No,
systems.
I think radar systems will update. Yeah, no, I do think radar systems will update. I think that they have to, right? There's so much going on that they'll have to do that. But yeah, the ship thing is a big problem. And it's one of the discussion points here in the States. What are we going to do? Because when we do put these offshore wind sites where we're planning to put them, there is shipping in and out of there. So they're going to have to find a way. I know they've thought about it, and I know they have shipping lanes already defined. But like we've seen once in a while, ships have problems and kind of go adrift and run into stuff. And hopefully, hopefully we do a better job of tracking them and catching them before they do some real damage. And having a radar system is one of the ways you would do that, right? And yeah, so this is going to be a bigger issue before it's over, but it's not insurmountable.
Well, sticking with offshore, there's a new venture from Myersk to. Oh wait, Rosemary. I knew it. Jump in there, Maersk.
You did that on purpose. You did that on purpose.
Maersk.
Yeah, that's
all
better.
right. There we go. You're welcome, listeners. You're welcome. Welcome to Rosemary's Grammar Hour. So Maersk, man, that is such a hard word for a Yankee to say. They are developing offshore charging buoys to hopefully find, basically like rendezvous points, checkpoints, where a ship could potentially go to battery power and stop, idle, and charge at these charging buoys. So obviously, offshore wind out there generating the power. Maybe then it goes to a substation, then to these charging buoys, and their fleet of ships can stop along the way, idle, charge, and then get going again. Rosemary, does this seem like a viable way to get? Because we've talked that the shipping industry across the oceans hasn't really shown much signs of moving to battery power. Do you feel like this is going to help get us there?
Yeah, I think it will be route dependent, because obviously offshore wind farms, even when we have floating wind, they're not going to be in the really deep waters, right? So you're not just going to go install an offshore wind farm every, 5,000 kilometers along all the existing shipping routes. But where there are wind farms, or where you could put one in on a, somewhat close to an existing shipping route, then that sounds like a great idea. And shipping is one of those really tricky decarbonisation problems. So I think it's pretty well established that for really short haul shipping, it's going to be electric, and maybe an idea like this could help bring up, that threshold a little bit further.
Alan, what are some of the challenges here? I mean, it seems like what Rosemary just said makes sense, that these will probably be smaller vessels. Because I'm thinking, if you have one of these container ships, that battery's got to be gigantic, and the power to fuel that thing up seems pretty significant.
Right. I think part of the issue they're having right now off the coast of Los Angeles, where all these ships are waiting offshore to unload their supplies and all the things that are coming over from China, is that they're causing pollution, because in order to keep the ship running, it's got to burn that really cruddy diesel fuel to keep the power on to keep the ship running. So you could reduce a number of emissions just by powering it, running electricity to the ship, so they didn't have to burn so much diesel. And they did recently push those ships off the coast of Los Angeles further out because of the pollution problem. There's so many ships off the coast of Los Angeles that they were having smog issues, which is not great, but maybe unload them faster. That may be an answer. We haven't figured that one out either. So instead, we're going to put these charging ports out in the ocean.
Replicants.
Yeah.
We need replicants.
Replicants, yeah. I watched Blade Runner the other day. Yeah.
We'll treat them better than they did in the movie. Yeah.
Yeah, well, yeah, yeah, maybe. So the if we're going to put charging ports out in the ocean so that we burn less diesel, that I think makes total sense. But I think it's sort of like a combination thing, Rosemary. Like if we unloaded the ships faster, there'd be less burning of cruddy diesel off the coastlines, thereby reducing the emissions and making the ships actually work better. But some of the to talk politics for a second. Some of the people that are most environmentally conscious are not taking care of that ship problem off the coast of Los Angeles, and I can't figure out like why. If you're concerned about the environment, then unload the dang ships. Let's go. But it hasn't happened. In fact, they've been stacking up more and more ships as we've gone on, and you got to think about the problem from a more global perspective, and sometimes we don't, right? We just say, oh, we have this problem, we have smog. Well, here's the solution: just move them further away so I can't see the smog. That's not the solution, all right? The solution is to fix the problem, which is unloading ships, and just like with everything else, everything's incremental. Putting charging ports out in the ocean, I think, makes sense, right? It would reduce emissions. It's a smart move. But there's other ways to help reduce emissions too, and we should be doing all of them, not just the one that gets us the PR.
I just listened to a podcast with Arnold Schwarzenegger the other day. We need him to train everyone in California, get them strong again to get these ships unloaded. He actually is very passionate about his environmentalism. It's really interesting, actually, listen to how much he's done
Is he
for the
vegan?
climate. Probably not, but I think he's made up for it. I think he's
vegan.
carbon neutral with all of his stuff. But he's a really interesting man. I didn't know. I learned a lot about him in this recent podcast. But moving on, more ship news, and this is, I think, part of the battery issue. Is there was a burned ship recently carrying like $500 million of luxury cars almost, and it caught fire. The crew abandoned ship. It was getting towed back to port, and eventually just destabilized and I guess turned over and sunk. So goodbye, all you Lamborghinis and $500,000 cars. There are a lot of Bentleys and stuff on there, but they're not sure how the fire started. But I think there's some speculation that it was an electric, because there were some all electric vehicles on there, and it's been well documented how difficult it is to pull out an electric battery fire. Alan, I mean, do you feel like issues like this are, I mean, imagine if the ship is filled with batteries, like the entire, ballast is batteries. There's going to be, and then they'll be up in flames in a minute, and they might not get the crew off in a situation like that with how fast these get engulfed. I mean, is this going to be a big thing that we see more in the future, or are they going to continue to get better at mitigating these risks?
Well, it depends what kind of batteries we put on them, right? On a ship of that size, maybe we don't put lithium ions on. Maybe we do some of these other alternative battery technologies so they don't catch fire and sink so fast. It's really hard, like you mentioned. It's really hard to put out lithium ion fires. I don't know if you ever seen one or been around one, but yeah, they're kind of nasty. You really can't do much besides let it burn itself out, which is
Let it burn out.
Yeah, that's what they did on the ship too. They kind of just put cold water on it so it wouldn't melt the steel, and off they went. Right, you just hope for the best. It'll burn itself out. We have to find a solution to that problem, right? Because you couldn't insure a ship, right? Think about it, Dan. If
One car goes up, yeah, and the whole ship is done, like that'd be scary.
that would be really scary, and I'm not sure he could find anybody to pilot the ship, and who would crew it. It just seems unimaginable, and we can't find a solution for that.
I think we are already making progress towards solving some of these new issues with lithium-ion battery fires. I know in Melbourne, Australia, there's a new big battery, and just before it was commissioned, one of the modules caught fire, and it took a few days to get it under control, but it never spread to another module because they have the safety. The design is safe, and they know that once a lithium-ion battery fire starts, it's hard to stop. So in that case, it was kind of like, it seemed like at the time, oh no, this is going to be terrible for the decarbonisation effort and installing more grid scale batteries, but it actually sort of seemed like, okay, this is the worst case scenario that's happened, and it was contained, and now we know what the worst is. We know that we can make this work, but it is going to require a different type of design for safety than for other systems. And I mean, you have to remember with ships, I mean, already shipping is already a cause of a lot of, potential for accidents and environmental destruction. So just because there is a new kind of problem, we also solve some of the old problems. So I think, it's just a matter of new problems come and we, engineers.
Wasn't the Melbourne solution the way they had set it up? Like all the batteries were containerized, but the little fire break was essentially that they separated the containers so that one wouldn't catch the next one on fire.
Yeah, we talked about that story because I mentioned that reminded me of fireworks. Like on firework plants, they put them in different, huts or little buildings, and they're all far enough away where if one goes up, they're not going to destroy the entire lot of them. Yeah.
So what do? You put like a battery-powered BMW next to a Chrysler? And
Well, that's the question.
Chrysler
They need to be
space.
in little, almost like the way ships have their their, what do you call them? Their hulls, right? Like if the EVs are all in their special spot where if one of them goes up in flames, they just like, close the doors and suck all the oxygen out. And that, I don't know. Yeah, I don't know what you do because, like you said, they burn so hot they could melt the hole in the bottom of the boat. Maybe.
Yeah, I think you have to shove it off the ship, right? I think you, in your dream world, you just shove it off the ship, write it up as a loss, and keep moving.
That'd be a heck of a
the way
YouTube
I do
video.
it.
Watch that.
Right.
Yeah, maybe that's the answer.
Well, sticking with offshore wind, the New York Bight offshore wind auction is, I guess, now complete, and 4.37 billion in winning bids. So as you look at this grid, which we learned from our attorney friend Kevin Ewing, they got their fun Tetris shapes and tons of acreage. So one of the winning companies, OW Ocean Winds East, paid $765 million for 71,522 acres. The largest was Bight Wind Holdings, paying $1.1 billion for 125,964 acres. So, Alan, you're shaking your head. This was a pretty big auction.
Crazy. When we did talk to Kevin about the auctions, you remember he had said that they had an auction that went over 2 days. This one went over 3 days. It was the third day where they finally settled the price. The starting price, if you add them all up, the starting price was $40 million for all the parcels. Ended up at $4 billion. So we're off by a factor of, is that 100, right? So they were off by a factor of 100. Usually you're off by a factor of 10 at an auction, and you hope to get 10x. That's your dream, right? And they got a factor of 100. So something is really askew there on what they thought the value of those sites were. $4 billion is not small amount of money. So there must be money in wind, right? There must be a lot of money in offshore wind. And the only thing I could come back with is they've already have PPA agreements to sell that energy, and they knew they could put those kind of high bids in and still be okay on the differential. That's the only thing that makes sense to me, because if you're riding on the day-to-day price of electricity in the United States, you could get burned by that. And in fact, the Europeans don't do it that way at all. They don't, at least they haven't allowed what they call a negative bidding process, where you actually have to pay money for the plot of land or ocean. Usually the Europeans are asking for subsidies. So the bids are on how much subsidies you need. In the United States, you're actually getting $4 billion up front just for the right to, or the permit to, or the right to submit for a permit to put wind turbines in. That's a huge $4 billion risk. That's that's for stronger stomachs than mine. Rosemary, do you find that amazing? $4 billion for some plots of ocean? That seems like a lot, right?
Yeah, I was actually at a couple of auctions on the weekend because me and my partner are trying to buy a house at the moment. And it reminded me a bit of what the property market is doing where I live at the moment. Not 100 times different, but there's been a couple of auctions recently that have been nearly 50% more than what we thought that they might go for. But I think that's probably our own naivety as much as it is the market. But it's crazy to me. I am not currently understanding exactly the economics of offshore wind, because when you look at the numbers, the Lazard levelized cost of energy for off wind, it's high. Capacity factors are good, but in places like at least Australia, I assume the US too, there's still onshore sites left with good capacity factors. There's a new wind farm being developed, a huge wind farm being developed in South Australia. It's over a gigawatt, I'm pretty sure. And it has a capacity factor of 48% onshore. So I know I talked to the developers of that recently, and they're like, yeah, why would we get into offshore when there's still, like amazing onshore sites like this available? So I don't get it, but I am prepared to accept that there must be more to it than I can see, and I must not be able to foresee the future very well when it comes to the technology trajectory, cost trajectory of offshore wind, because, this isn't just one silly investor that drives up prices like this, right? It's a bidding war that causes an outcome like this. So I'll be really interested to see, what happens with the next ones, and also, in 10 years' time, are these projects profitable for the developers? Yeah, it's a very interesting place to watch.
Well, speaking of offshore wind auctions, despite the boom here in the US and the boom overseas, EU is only on track to build about half of the wind energy it needs to meet their Green Deal, getting their goals met by 2030. So, in 2011, the EU only built 11 gigawatts, and they're set to build 18 gigawatts on average between 2022 and 2026, but they really need about 30 gigawatts a year. And of course, if they fall behind now, it's not 30 gigawatts a year. There's going to have to be more than 30 gigawatts to catch up. Rosemary, what's your take? Is this becoming unrealistic? Can they actually catch up and speed? Obviously, bigger turbines continue to come out every year, but they maybe just sub in some extra, enormous ones to make up some ground?
I think they absolutely could do it, and I think maybe they will do it now that there is so much incentive for Europe to sort out its energy independence and get away from really, really volatile fossil fuel prices. So I wasn't feeling very optimistic about their capabilities to get the job done until recently, over the last 6 months or so, when gas prices started to rise really high. But I think what they need to do is to sort out the bureaucracy and transmission. I know that they have huge problems in Europe putting in any major new transmission lines, and I think maybe now that people are really seeing the pain of an energy system that has not proceeded smoothly through the transition. Now people are seeing pain in their own personal electricity and gas bills. I think you might start to see less opposition to major new transmission projects that are so desperately needed to get the renewables from where they're available and cheap to where people want to live in Europe. So yeah, I think that's really the key, though, is the bureaucracy. It's, it's so hard to get development approvals and everything you need for new projects. And then probably number one is transmission.
Well, how does, as we talk about energy redundancy, what is going to be done with redundancy, right? I think the issue that a lot of Eastern European countries and now Germany and a number of others are having is Russian natural gas and having a backup plan. Wind is obviously going to be really aggressively pursued. It already was, but this Ukrainian situation is going to accelerate that. But they're going to have to balance the grid, right? They're going to have ways to dealing with multiple energy sources. So the thing I always try to figure out here is what's the second piece, right? Is it nuclear? Is it solar? Or is it both? It's going to, and can you create an economy, a civilization without some level of natural gas / oil? I don't know if you can. At least not in the next 10 years. I don't think you can. You can reduce it, but I don't think you can eliminate it. I just don't know how Europe's going to do it. It doesn't have the infrastructure.
Yeah, but they don't need to switch off they don't need to switch off gas tomorrow. They need to use less and less and less. So it's very complementary to variable renewables. They still have all of their gas turbines there, and if they use them only when if they build out a lot more wind and solar, they'll still have the gas there to fill in for those times when that's not right. So I think that in that sense, it's not a matter of switching off gas tomorrow. I mean, not all their gas comes from Russia. And even if it did, reducing would still, be a big help. But I think for Europe, for Northern Europe, their problem is largely heat. I mean, that's mostly what they use gas for, and that's what all their storage problems are around, that, they need just a lot of heat in the wintertime. And there, I think that they need to really start getting serious about energy efficiency and heat pumps, but also alternative forms of heat, like, solar thermal, which they're using a lot in Scandinavia. You might be surprised that somewhere so cold can actually get a lot of heat from solar thermal, and they store it, seasonally. I think the more that they can come from different sources, the faster they can go. Because I've seen a lot of talk about, we just need to roll out heat pumps everywhere. And I think we do, but that needs to really come in combination with new transmission, because it's going to massively increase electricity demand. So if I was in charge of this in Europe, I would be starting with energy efficiency, solar thermal where you can, and roll out heat pumps and transmission in tandem to gradually move away from reliance on these volatile fossil fuels.
And I'm not sure, Alan, do you use a heat pump? I'm not really familiar with what a heat pump is, but they're not very common in the U.S. Rosemary, what's the story? Because I know they're really heavily used elsewhere.
Yeah, well, in Australia, everyone has heat pumps because it's the same as an air conditioner. If you've got an air conditioner, then you can use it as a heat pump as well. But basically, a heat pump is just a way of transferring heat from, there's some heat in air even when it's cold. Even if it's below freezing, there's still some heat in the air. And a heat pump is a way that you can, via compression and decompression, the physics kind of resembles magic in this case, because you end up with a lot more heat out than the electricity you put into it. So where a gas boiler might be 90%, maybe 95% efficient at turning the energy and gas into heat, a heat pump will give you, in Australia, 300-400% efficiency from the electricity that you put in. So that's in a nutshell how they work, but it does sound like magic, which is why
Rosemary just
love them.
violated the first law of thermodynamics. At least one of them, maybe two of them. Come on,
above 100%. I don't understand. Is that the one? Did I get it?
Well, it's a coefficient. It's a coefficient of performance, not an efficiency. It's wrong of me to say that they're 300% efficient. It is just moving heat around. You don't create any heat, but it feels like you're violating the laws of thermodynamics because, from your point of view, you've put in, 100 watts of electricity and you've gotten out 400 watts of
Well, in the
heat.
spirit of you correcting my grammar, I'm going to say that this explanation was very unhelpful and I didn't really understand. I have no further understanding of how heat pumps work.
There's a flag on the play, right?
Yeah,
There's been
so you gave
penalty.
it a good shot, but we're not quite there. I'm assuming there's a magic wand involved and maybe some
keep
sort
going,
of
but I
dust,
think we probably
maybe
don't.
magic beans.
No.
I don't know.
Stop that, Rosemary. You're fine
You
where you're at.
sprinkle the
Yeah.
dust on your air conditioner and then it becomes hot. Noted. Well, moving on, there's been a lot of cuts in the workforce. We'll start with Siemens Gamesa. They've laid off 37% of their employees at their wind nacelle plant in Hutchinson and in its Iowa turbine plant. So, Alan, these are in mid-America, in the Midwest here, closer to where you grew up. This is not a good sign. Obviously, we know the supply chain issues, the profit margin pinches, the inflation. Are they all leading up to these cuts from Siemens Gamesa?
Absolutely, but I also think it's maybe a combination of offshore wind taking out the majority of the future and onshore wind stepping down a little bit. I attended the Blades USA Forum last week in Austin, Texas. Yeehaw, right? Well, it was warm there compared to Massachusetts.
Yeah, why aren't you wearing a cowboy hat? You're wearing glasses, but no cowboy hat. What's the
that's
deal?
true. They should have given us a cowboy hat as one of those little party favor things they hand out at conferences, but they didn't. That's very odd.
They get expensive. They're very handcrafted and well made when they're...
Yeah.
Yeah.
So
get up there?
when I was down there, one of the discussion points that came up during the conference was the quality of the wind turbines out of the factories, and that the engineers will never admit defeat, right? Engineers always design perfect things. If there's a problem, it's in manufacturing. Okay, fine, sure. And my take on it was, well, the problem that manufacturing has is that you hire a bunch of people who may not have any experience, who's built a wind turbine blade, who has it on their resume, wind turbine blade builder. Not many people, so you have to train them. You train them, and then you lay them off, and then you bring them back, then you lay them off, and then you close the factory, you move the factory from Iowa to New Jersey. You're just constantly changing people. Building blades and making wind turbines is a really difficult thing to do. That's why we have trouble with it. Bringing staff on and off, which financially you have to do, doesn't make quality better. It's going to make it harder. And everybody who's left remains has obviously a more difficult task to do. So, it's part of this whole turbulence in the wind industry of getting consistently high quality products out the door. And I think the engineers and I think all the people that work there are trying to do that. But it is hard to do when you have such fluctuating workforces. I don't see this Iowa, Kansas situation as being beneficial, right? You like to keep everybody. If you've got them trained and they're quality employees, you like to keep them. That's your dream. But the marketplace is not allowing that right now. And I think as an owner operator, I would be concerned about that those fluctuations can mean problems when I get the wind turbines installed, and that's not good. And Rosemary, you used to work at one of the OEMs, I'll call it, that built blades. Did you have that same sort of issue, just the kind of the ebb and flow of manufacturing people in and out?
Yeah, and it depends where in the world as well. I know that it's common in, all manufacturers in the US struggle with even if they're not having to lay off people because of, a lack of demand for the product, there is still a high churn of employees. And there's certain places in Europe where that's true. It's always based on pretty local factors, what other kinds of jobs are available and that sort of thing. But in general, wind turbine blades, at least, when they open a new factory, they're going to staff it nearly entirely from people who have never had experience making wind turbine blades before. They'll bring in, obviously, a lot of people, engineers, and also they bring in good workers from other factories, maybe for the first month or several months to get them up and running. But you're right, you do rely on some people sticking around long enough to kind of continue that culture of quality. And where a factory can't achieve that for whatever reason, it makes it incredibly hard to maintain quality at the required standard.
Yeah, it's trouble. We're going through the same thing in the aviation industry, right? The big knock on Boeing right now is employees and the culture, the quote unquote culture, whatever that means. I think of culture as just people, right? And turbulence in people leads to turbulence in the products. It just has to. There's nothing to do about it. But like in Europe, and there's a lot of discussion in Europe about stabilizing the wind industry, we need to do the same thing in the United States. If we're going to rely upon it to put these wind turbines out in this $4 billion plot of ocean we just created, we're going to need some consistency there. And hopefully we can stop the churn and do what needs to be done. Deliver high quality products consistently. And that takes good employees, trained employees to do that.
Well, and shareholders for Siemens Gamesa have been pretty upset. I mean, that's actually probably an understatement. They've been outraged, furious at management. There have been 4 profit warnings in the last 18 months. They've lost billions of their market value. And this past year, they had a 289 million euro loss, basically on order backlogs and all that. So that was actually just the first 3 months of this fiscal year. So, Alan, I mean, there's a lot of turmoil in Siemens Gamesa. What do you think their path is forward to start righting this ship and getting back towards profitability?
It's stability at the top, but also playing the long game here. It does seem like there's a lot of shareholder input into the company and demands for it to be profitable right away. And you would think a large industrial company like this would be profitable. There is money to be had in wind. clearly there is. We just saw $4 billion of it. But for the OEMs, it doesn't seem to be profitable. And they are losing money. Most of them are losing money. I think Vestas may be the only one that did make a little bit of money last year. That's a problem, not so much that the companies can fix, but that the countries they're in are going to have to get their heads around. You're talking about politicians and the communities stepping up to figure out how they can help. Because if they don't, they're going to lose some of these manufacturers. It's almost inevitable right now. You're going to either going to treat these wind turbine manufacturers as a national asset, a critical national asset, or you're not. And I think Europe should start defining them as critical assets. It doesn't mean that you have to take it over and run it. Like you don't want Germany necessarily running a wind turbine company, and you sure as heck don't want the U.S. government running GE's wind turbine operations. That would not be smart. But you have to stabilize what's happening. Right now. Steel prices have gone off the charts, right? All your supplies, main supplies, have gotten super expensive, and the supply chain's all messed up because you can't deliver anything on time. Those are not specific to wind, but it is impacting wind probably greater than some other industries. So it takes prioritizing. What are you going to do first? I think your energy infrastructure is one of those high national security items. You should be prioritizing the electric grid. You should be prioritizing natural gas. You should be prioritizing home heating, like Rosemary was saying. They need to be doing that. And I think finally, the OEMs are starting to step up and be vocal about it to the right platforms. U.S. national government, the EU government, and their local countries too. And Rosemary, is there another way to address this problem besides basically declaring it a national emergency?
Yeah, actually, I don't know what the solution to this problem is, but it has occurred to me that more and more wind turbines are becoming like it's a commodity. You know, it's just purely sold on price, and everyone's cutting. But I mean, it's not a commodity. It's an incredibly high tech thing with so many engineers are involved in designing. Quality is important. Safety is important. It's really strange to see it be just purely a game of reducing costs and reducing, which, it's very keenly felt by anyone working in the industry now. It's just there's no money around for, improving technology or anything. It's got to be, we're still improving the technologies, obviously, but it's all done within this just overarching framework of reduced costs, work faster. It's really hard, and it's one of the reasons why I wanted to move on from working solely in the wind industry, because it has reached that, it's a mature technology, but how long can it survive if no one can make it profitable? It's not a long-term thing. All
the OEMs, major OEMs, signed a letter to the head of the EU, the president of the EU, and basically said, we can't. The governments need to do something here. And they had a couple of things that make sense to me, right? No negative bidding, which is just what happened off the coast in New York, right? That if you're having the power companies pay for access to certain plots of land, it leaves less money on the table for wind turbine manufacturers. Yes, it does, right? In the case of the U.S., we just took $4 billion off the table that could have gone to wind turbine manufacturers, which would have helped tremendously. And at the same time, you have to worry about, and the letter to the EU president said this straight out, we have to worry about China. Like at some point, China can start dumping wind turbines. They're already doing it in South America, Africa, parts of Asia, such that it is part of the Chinese government plan of sort of Belt and Roads, whatever that plan is that they have to try to expand their network of influence. Wind is part of that system.
I think people are starting to become aware of just how much that is not a strategy for the future, to just allow other countries that you're not particularly politically aligned with, just allow them to monopolize critical things. I mean, you saw it with like battery supply chains is a good example, and other critical minerals. People are starting to cotton on that, China's been very smart with their strategies surrounding all those kinds of things, but now we're starting to see people maybe belatedly realize that this is not going to take us to a good place in 10, 20 years. And so I think now is the right time to start to reassess.
But you would like for Nordex and Siemens and pick them, all of them, all the OEMs to be making, 5, 10% a year, right? You would like to see that sort of turn on investment. They're not there, right? They're at zero or negative. That's not a place they can live there very long. Something needs to change like now. We can't be having the same discussion a year from now. We need to get on it now.
Yeah, and Nordex has laid off, looks like about 1 in 5 German workers just this past week. They've cut, looks like 600 from their Rostock facility. So it's not limited to Siemens Gamesa. Everyone's really in a crunch at the moment. And we'll see if this comes to fruition. There's still innovation being had. Petrofac, which is a global company, they operate energy facilities. They've entered into an agreement with Seawind Ocean Tech to deploy some 6 megawatt, 2-bladed floating wind turbines. So they're going to have a 126 meter rotor diameter. It says rotor speed, maybe like 21 RPM at their rated power. Rosemary, you have a ultra successful video on YouTube about explaining the difference between 2 blades and 3-bladed wind turbines, because so many people have that question of why have they evolved to be this tri-rotor design. So do you see this being successful? But it looks like it has the backing. We'll see. But why is this the first time this is being tried, and what's the value proposition here?
So first, it's not the first time it's being tried. There's always been 2-bladed wind turbines, and including Enercon had a offshore 2-bladed, no, not Enercon, Envision had a 2-bladed wind turbine for offshore not that long ago. It was a really interesting design, and the blade design was done by LM Wind Power. So I talked to the engineers working on that. But so that out of the way. But the main difference between 2 and 3 blades, the reason why you nearly always see 3 blades is because 2 blades is not a very stable design. And the way I explained it in that video that you referenced, it's like when you see a figure skater doing a pirouette with her arms out, she turns more slowly, and then they bring their arms up, and then all of a sudden they're turning very, very fast. And so a 2-bladed wind turbine, when the blades are horizontal, that's like the figure skater with her arms out, and when she's got them up, that's like a 2-bladed turbine with the blades straight up and down. So when the turbine is yawing, so turning to face a changing wind direction, the force that it needs to turn changes a lot depending on what position the blades are in. So that's one reason. Another reason is that every time a wind turbine blade passes the tower, you get a little bit of an effect from the tower passing. That also is smoothed out a bit more from having 3 blades. So in general, wind turbines, you want the smallest number of blades possible because that uses less materials, it's easier to transport, all those sorts of things. But you usually have 3 because it's more stable. But you can overcome all those problems. And I think that this one is a teetering design, right? Which means that they get around these problems by tilting the rotor a little bit, depending on the position of the rotor, whether it's horizontal or vertical blades. And that's a design you see on a lot of small wind turbines. There's a really common 2-bladed wind turbine in Denmark. I think it's called Gaia, and I did check up on them recently. I think they've gone out of business, but it's all over Danish wind farms on the west coast of Jutland. And those ones, I just have a system of springs, and so it's just, a passive system that they kind of make up for some of these, force disturbances that happen from having a 2-bladed design, just constantly changing. They make up for that with springs. So I'm assuming a 6 megawatt machine.
No, I think it is. Right? I think it is going to have springs. Yeah, that's what it sounded like. Where do these springs go? What are these? What is this thing? On the blade and the hub on the tower?
Between the like on the hub basically, so you control the angle that the rotor makes with the tower, say. Yeah, and I mean I've seen it, and you can look at my my video to see that.
Oh, you don't want to give away all your secrets.
I
You're on
have
the
to go to
podcast.
Rose's
Got
YouTube
it.
channel. Okay.
It's just very hard to it's very hard to describe things with words, you know. Engineers are visual, spatial kind of people. But the reason why we don't see a lot of two-bladed wind turbine designs out there isn't because no one knows how to do it. There've been plenty of examples of people trying and producing successful engineering of a two-bladed turbine. It's always the economics in the market. It's it doesn't provide a benefit actually for the cost. Customers haven't wanted it. But I mean, for offshore, the installation cost is, an issue. And so two-bladed design does make more sense if you can it looks like it's a solid single blade actually that, they're attaching in the center. If they can save a lot of money in their transport and installation costs, that's good. The turbine currently is very small for offshore, so I'm not sure what they're getting at there. I'm really surprised that they think that 50 years is the right design lifetime. In 50 years maybe we've got nuclear fusion. It's a bit weird to make a 6 megawatt wind turbine that they think is going to be it's. I don't give good odds for this specific wind turbine, but there's definitely no engineering reason why not having two blades on a wind turbine.
All right. Well, that's going to do it for this week's episode of the Uptime Wind Energy Podcast. Thanks so much for listening. Be sure to subscribe in the show notes below to Uptime Tech News, our weekly newsletter, as well as Rosemary's YouTube channel, where you can check out her 2-blade versus 3-blade rotor video. We'll link to that so you can check it out. And be sure to subscribe wherever you listen, and we will see you here next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. This is why it just makes sense to install a WeatherGuard Strike Tape LPS upgrade the next time your technicians are going up tower. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.